Okay, learning target for today. We'll be able to use the law of sines, which of course we need to have a flamingo go by. All right, right triangles are really awesome, but sometimes we just have a triangle. And so if we don't have the right angle, we cannot use the Pythagorean theorem, nor can we use SOHCAHTOA. All right, so our math toolbox just says, hey, we need another tool. Okay, we actually need two tools. One of them will be today with the law of sines. All right, and then the next lesson will be the law of cosines. Those are the next two tools we'll need in our math toolbox to solve triangles. Right? Notice I didn't say solve right triangles, I said solve triangles. And okay, we got another bird going by here. The law of sines. All right. Now I can do either form here. There's my picture, right? Triangle ABC. Notice C is not a right angle. Notice there's no hypotenuse, right? Instead of two legs and hypotenuse, we just have three sides. And so I can either write the proportion with the sine of the angle in the numerator and the length of the side in the denominator, or I can write the proportion with the length of the side in the numerator and the sine of the angle in the denominator. All right, there are no legs, no hypotenuse here. Now, I only need two ratios for a proportion. So if you're looking at those like, how am I going to solve an equation that has three pieces? We're only going to work with only two at a time. Right? So we can all say, hey, maybe this is what I have to solve. Right? Maybe I know three of those pieces. I can find the fourth piece. Or maybe I've got something like this where I know three of those pieces and I can solve for the fourth piece. Right? So two ratios form a proportion. And again, how am I going to decide if I want the sine of the angle in the numerator or the length of the side in the numerator? It'll depend on what we're looking for, right? Whatever I'm looking for, I want that in the numerator. It makes life a little bit easier, right? So if I know three of those four terms, I can solve the proportion quite easily. The parade of birds continues. There goes an ostrich. Okay, so solve the triangle. Okay, so I know three pieces. I want to find the other three. So what should we find first? Well, we know angle A, we know side A, we know angle B. So I guess we have to find angle B. Right, so I can use sine of B compares to B the same way sine of A compares to A. Why did I put sine of B in the numerator? Because I'm trying to find angle B. All right, whatever I'm looking for, I want that in the numerator. Okay, so plug in what I know. Multiply both sides by 13. I now have sine of B isolated. So I'm going to have to grab a calculator. I'll take the sine of 40. I can multiply that answer by 13. Finally, divide that whole thing by 16. All right, so here comes my calculator. Find the sine of 40 degrees. Multiply that by 13. Divide that by 16. And so now I know that sine of B is approximately 0.5222, and then a bunch more decimals flying on by there. Oh, I want angle B, not sine of B. So if I actually want angle B, I'll have to do the inverse sine of that decimal and say, oh, it's about 31 degrees. Directions, oh, the directions did tell me where to round off. They said round off the nearest tenth. Okay, so there it is, 31.5. I can add that to my diagram. Woo! What should we find next? Well, we know the three angles have to add up to be 180 degrees. So C is going to have to be 108.5. I can add that to my triangle. Right? I can, because it's a triangle, I can still use the fact that the three angles must add up to 180. We need one more side, it looks like. So we got an emperor penguin wandering on by. And so how am I going to find side C? I cannot use the Pythagorean theorem. I don't have a right angle. So instead, I got to go back to the law of sines. And again, since I'm looking for side C, I want that C in the numerator. Plug in the three values I know to isolate the variable C. Let's multiply both sides by the sine of 108.5 degrees. So it's time for my magic calculator. Right, so I'm showing step-by-step work, but then I'm going to have to grab that calculator. Right, I'm not going to figure out the sine of 108.5 degrees by hand. Then I got to multiply it by 16, and then I have to divide that by the sine of 40 degrees. And it looks like we're very close to 23.6. Again, I can add that to my diagram, and I have successfully solved the triangle. Okay, now if you think back to when we were taking geometry, right, and we had a triangle like this, and we were doing proofs, this is side, side, angle, right? We have a side of 16, a side of 13, and an angle of 40 degrees. Right? The law of sines will also solve triangles if it's angle, angle, side, or angle, side, angle. Those are the three options that we have where the law of sines will save the day. Right? And of course, if we know two angles, we know all three. And so for angle, angle, side, and angle, side, angle, we don't actually ever have to use the inverse sine function. So let's take a look at one of those. Okay, now this is an emu. That's not an ostrich. That's an emu. So we're in Australia instead of Africa. Right, so here's an angle, side, angle. Right, I know an angle, the enclosed side, and then the angle. All right. And again, if I know two angles, I can also immediately find the third angle, and I don't need the law of sines. I don't need a calculator. All right. It's got to be 29 degrees, and I can add that to my diagram. All right. Although the proofs for angle, side, angle, and angle, angle, side were different, when it comes to the law of sines, they're the same, because the first step is find that third angle, and so now we got all three angles and we got one side. Okay, I'm going to go look for side B, I'm going to look for side C. So these are going to be my two setups. All right, I can plug in the numbers I know. And definitely I'm going to have to agree with Yoda here. I need just meant a parade of birds. All right, so how do I figure out B? Multiply both sides by the sine of 70 degrees. Grab that calculator. punch buttons like crazy. There's an answer. I can add it to my diagram. How do I figure out side C? Well, let's multiply both sides by the sine of 81 degrees. And again, punch buttons like crazy on the calculator. Get approximately 20.4, add it to the diagram. Alright, so I had to use the law of sines twice. Right, I found the third angle just by adding up to 180, but then for the two missing sides, I had to use law of sines. And let's try one last example here. Uh-oh. Where's my picture? Well, if I don't see a picture, draw a picture, right? Now, since I really don't know what side is the longest or what side is the shortest, I'm not going to worry about how it looks, right? I just know that one corner is A, one corner is B, and one corner is C. I'm not going to worry about trying to make it look like it's in scale or anything. And this is angle, angle, side. So again, my first step, well, let's find that third angle. I know the three angles must add up to 180. So piece of cake, the missing angle is 84 degrees. Now I've got to find my two missing sides. So I get to use the law of sines to find side B. And I get to use the law of sines to find side C. So I can plug in the values I do know. So for sine of B, for side B, multiply both sides by sine of 66. It turns into a game of pushing buttons on the calculator in the correct order. If I do that, I should get 12.8. I can add that to my diagram. For side C, let's multiply both sides by the sine of 84 degrees. I now have C isolated. Again, it's a game of can I push the buttons on the calculator in the correct order. If I do, I should come up with 13.9. Right, this is why it's so imperative that you show step-by-step work, because it is so easy to make one tiny push of the wrong button on a calculator and get a really bizarre wrong answer. And so your answer itself won't tell me whether or not you're understanding the process. Seeing that step-by-step work is what's going to really let me know that you know what's going on here. Right? Now for the law of sines to work, I have to have an angle and its corresponding side. Right? So in each of these examples, there's at least one pair where I knew both the side and the angle. And again, please notice that the diagram does not have to match reality. If you take a look at my picture, you'll say, hey, 13.9 is bigger than 12.8, but 12.8 looks like the longest side on that picture. Again, the picture will not be to scale. The picture will not be in proportion. Don't worry about the artistic perfection of the picture. Don't worry if the math doesn't seem right. Or you might say, hey, look, that 84-degree angle doesn't look like it's bigger than the 66-degree angle, right? I'm not going to concern myself with that, right? I want to make sure I can just get the calculations in, right? That's going to be a crazy situation. As long as it looks like a triangle, you're going to be okay. And we have one last. This isn't a real bird. I mean, yeah, a flamingo's a bird, but come on. I think the thing wandered out of my garden and onto the PowerPoint here. Okay, here come the real flamingos. And it looks like we want to have a worksheet. Da-da-da, and there are the flamingos.